All right, we're back. We're working on a second problem. In this problem, you'll see we're going to calculate the mean return and the sample standard deviation for Apple and for the S&P 500 using the data to the right. All right, so what I've done is I've grabbed historical data, monthly data, from January 2014 all the way to December 2018. So I have 60 months of data for both Apple and for the S&P 500. And the objective is to calculate the mean and the sample standard deviation. Now, what formula should we use? Remember in the last video I said that if you saw a table with probabilities that were given, we're going to use the formulas on the left. If you have historical data only, historical returns, we're going to use formulas on the right. Okay, so let's start with Apple. All right, in Excel, this becomes really easy. So all I have to do in Excel to calculate the arithmetic mean is I say equals average, and I highlight the time series of returns. And that gives me a monthly return of 1.56% per month. So if you think about that, 1.56% per month, and if I times that by 12, that's about 18.72% per year over that 5-year period. Apple has done very well during that 5-year period. Let's look at standard deviation. Again, when I calculate the standard deviation, I say equals, and I enter the formula STD EV, standard deviation, dot P is the population standard deviation, which we haven't talked about. Dot S is the sample standard deviation, which we have talked about. We're going to select that one and highlight the time series of returns there. And I have a standard deviation of historical returns of about 7.4%. I'm going to do the same thing for the S&P 500, and we'll try to draw some conclusions here. Equals average. The S&P 500 has averaged about 0.56% per month. That's about 6.7% per year during that 5-year period. The standard deviation is 3.15%. Okay, so here I have the mean for both of these assets and the standard deviations for both of these assets. When I calculate the mean in Excel, it's literally calculating this formula. When I say equals average and highlight the time series, it's calculating this formula. When I calculate the sample standard deviation, it's calculating this formula for the time series of returns in question. So this is how I would go about calculating the mean and the sample standard deviation for various assets. So that was a great problem. Before we leave, let's do a couple of other things. In a previous video, we talked about skewness and kurtosis. So skewness and kurtosis are measuring, sorry about that. Skewness and kurtosis are measuring the non-normality of the distributions. So let's also calculate both skewness and kurtosis, and you'll recall that skewness and kurtosis are calculated this way. Calculating these by hand isn't pleasant, so we're going to use Excel to do this. These are the formulas that Excel will use to calculate these things. If I say equals skew and highlight the time series of returns, I get a skewness on Apple of negative 0.2169. That's not in percent, that's just a skewness of negative 0.2169. To calculate the skewness for the S&P 500 returns, I get a much more negative skewness of negative 0.56, which means both Apple and the S&P 500 have negative skewness. To calculate kurtosis, you remember that formula. Highlight the series of returns. and I get a kurtosis of 0.1145. It's pretty close to 0. So it looks like the thickness of Apple's return distribution, the thickness of the tails in that return distribution, are fairly normal for the S&P 500. You see I get much more kurtosis. All right. So we have mean returns. It looks like Apple has certainly outperformed the S&P 500 at the monthly level over the last 5 years. However, Apple has also had a much greater standard deviation than the S&P 500. What's also interesting is the following. We have Apple, both the Apple and the S&P 500 have negative skewness. So they are distributed. The distribution looks a little like this, where you have a longer tail on the left-hand side. And Apple has a kurtosis close to 0. So Apple probably looks more like this purple line with respect to the tails, the thickness of the tails of the distribution here, whereas the S&P 500 has much thicker tails. So if you look again at the S&P 500 kurtosis, you have a kurtosis of 1.35. So again, we can make economic inferences regarding these statistics of skewness and kurtosis as well.